We're going to look at problem number 8 on page 547. And in this problem, we're talking about money in a bank account, and it's growing at an interest rate of R. We're told that we're going to start with $1,000 in the year 2000. So let's just start with part A. And in part A, we are asked to write a differential equation satisfied by M, the amount of money in the account at time t, measured in years since 2000. All right, so here we go. When we're writing a differential equation, that means we have a derivative, and it's going to be dm dt. We're interested in how the amount of money changes over time. Well, it changes according to the interest rate, which in this case is R. And we simply take R times M, and that tells us how much it changed. So we've written our differential equation. It has a derivative, and it tells us how it changes since 2000, which is we simply take the interest rate times the amount. All right, so in part B, we're asked to solve this differential equation. Now, when it comes to solving differential equations, we learned the quick shortcut yesterday that we just simply do m equals our initial value, m sub 0, e to the rt. So if we've got that memorized, it's quick and easy. Otherwise, you've got to go through and put your m's together and your r and dt on the other side, integrate both sides. And it's a long process, but it always comes out to the same thing. Now, when we solve this, we do know m sub 0. We know that we were starting with $1,000 in our account, so we can put that in right there. All right, and we're done with our solution. So part C simply asks us to sketch this for interest rates of 5% and 10%. So we have two situations. One of them is m equals 1,000 e to the 0.05t, and the other one's going to be m equals 1,000 e to the 0.10t. And we know that this is an exponential graph. So to do this, I'll just start off knowing that they're both going to start right here at 1,000 at time equals 0. And that's the year 2000. Maybe I can put 2000 here. That's where we started. Now we want to head out to 2030. So let's figure out what those values are. So let's pull up our calculator. And in our first case, we are going to do 1,000 times e, let's see, second, e to the 0.05. Did I get a point in there? Let's go back. I think I missed the decimal. So there it is, 0.5 times 30, because it's 30 years. So there's our first value. And then we're going to do the same thing. Let's just grab the whole thing again. And we just need to change the interest rate to 0.10. And we press enter. And we can see the two amounts. Clearly having interest rate of 5% and 10% ends up in very different amounts. Oops, I want to see those amounts. So one of them was 44.81 and the other was 20,085. So let's see if I can remember those. So 44.81 and the other was 20,000. It's going to be quite a bit higher. Let's just estimate her up about there. 20,085. So 0.85. Oops, but those dots aren't going to be there. They're actually going to be here and over here at 2030. So our first case with 5%, oops, that's the problem when you use this technology. Sometimes it's hard to draw. So in this first case, we take this, and it's going to grow exponentially to this. And the second one, it's going to grow exponentially to there. And so this is our 5% curve, and this is our 10%.